Before beginning the demonstration of the lab sheet, let me show you the environment which I'm using. So I'm using WSL, which stands for Windows Subsystem for Linux, and it gives you a Linux-like terminal to work with. So let me show you. So this is WSL, and you can navigate to the root directory and then to the MNT folder, and then you'll be able to see the C, D, and E directories from your Windows operating system. Hi everyone, this is Satvik, and today we'll be solving lab sheet 6 together, which is based on functions and storage classes. So what is a function? Function is a block of code which only runs when it is called. You can pass data known as parameters into a function. Functions are used to perform certain actions and they're important for reusing code. So let's say in your code you want to perform some task and you want to do that task repeatedly. So instead of writing your code repeatedly inside the main function, what you will do is that you will create a separate function and you will call that function as many times as you want. So this technique is called modularizing your code. So as we go through the examples, I'll let you know all the terms related to function calling, passing parameters into function, etc. And for most of the problems, we will use pass by value technique. There is also another technique, pass by reference. So that we'll see whenever what passing techniques are required and how we are calling functions. So let's first start with the first question, which is printing all Armstrong numbers in a given range. So this is the definition of an Armstrong number. An Armstrong number is an n-digit number such that the sum of its digits raised to the power n is the number itself. For example, 153 has 3 digits. So 1 raised to the power 3 plus 5 raised to the power 3 plus 3 raised to the power 3 is equal to 153. This sum is same as the number 153 itself. So 153 is indeed an Armstrong number. Similarly, all single digit numbers will be an Armstrong number because the number of digits are 1 only. So we'll raise 1 to the power 1, which is equal to 1, 2 to the power 1, which is equal to 2, 3 to the power 1 is equal to 3, and so on. So our goal is to print all Armstrong numbers within a given range. So let's start coding this up. So the environment which I'll be using is Sublime Text for the text editor, and I'll show the output and compilation commands on the terminal. So first, let's include all the standard libraries. This is the standard library stdio.h. And for this function, I'll also include math.h library. You'll see why this is required. Now, let's start with the main function. So as you must be seeing that I'm calling main also a function. So this is also a function. This is like a driver function for the code. The compiler calls this function and whatever is there in this function gets executed. And then main function further calls other functions for their execution. So for this program, I'll create a function is Armstrong. So this is the return type of the function, which is an integer. So this function returns an integer. This is the name of the function, which is Armstrong. And then I'll also take in input parameters. I'll take n as the input for this function. Now, what I'll do is that I'll store the value of n in a temp variable. You will know why I'm doing this. Then I'll create a digits variable because I want to raise the individual digits of the number to the total number of digits. Like the total number of digits is 3 here. So I'm raising 1 to 3, 5 to 3, 3 to 3 and adding all of these. So I also want to know what is the number of digits and I'll also initialize sum to 0. Then this is the code for calculating the number of digits. So essentially what I'm doing here, you can also write this as while n is greater than 0. So what I'm doing here is that I'm dividing the number by 10 and incrementing the digits variable. So how is this going to give you the number of digits? Like let's suppose we have 153. So also you must be knowing that since n is of the type integer, so when we divide an integer by 10, like let's say our n is 153, so 153 by 10 normally is 15.3, but since it is an integer, it will typecast it back to integer itself. So always it rounds down the floating point to the nearest integer which is lesser than it. So 15.3 gets rounded down to 15. So you should remember this. 153 becomes 15 here, and I'll increment the digits to 1. Then since 15 is greater than 0, we'll enter this loop again. 15 divided by 10, 1.5, round down to 1, and digits becomes 2. Now 1 is greater than 0, 1 divided by 10, 0.1, rounded down to 0, digits becomes 3. Now since 0 is not greater than 0, so this loop terminates and we get digits as 3. So now since I've changed my n, I'll have to reset it back to n. So this is why I had stored the value of n in the temp variable. I'm resetting the value of n here. Now I'll be calculating the sum. So again, while n is greater than 0, I'll add what I have to add in the sum variable. So what I have to add is the number raised to the power the number of digits. So n mod 10 gives me the units digit every time. And then I'll divide the number by 10. So let's say I have 153. First I'll get the number mod 10. The number mod 10 always gives us the units digit of that number. So 153 mod 10 will give us 3. 3 raised to the power digits, which is 3. 3 raised to the power 3 is 27. Sum plus is equal to 27. So sum becomes 27 here. Now I'll divide the number by 10 because I'm done with 3 now. Now the number n becomes 15. So again, I'll calculate the remainder mod 10, which is 15 mod 10 is 5 here. 5 to the power 3 is 125. 125 plus 27. Sum will now store 152. And I'll again divide by n because I'm done with 5 also. So now I have just 1. 1 mod 10 will be 1 only. To the power 3 is 1. So 152 plus 1 is 153. And 1 divided by 10 will give me 0. So now this loop terminates and I have 153 in my sum variable stored. So if you don't know this, this is the modulus operator. This gives the remainder upon division by 10. If we use 10 here, or if we use any other number, then it will give the remainder upon division by that number. So division by 10 will always give us the units digit in any number. So at the last, I just want to check if the sum is indeed equal to 10 because I have again changed n here, so I'm using the stored value of n. If this sum is equal to 10, then this function will return me 1. Otherwise, this function will return me 0. So let's declare two variables for taking an input from the user. And I'll scan those variables. You must be knowing the syntax of scanf and printf by now. And I'll store the values in the variables x and y. Then I'll run a loop from x to y. And I'll check if the number is Armstrong, then I'll print it to the output screen. So this is the function call here. I'm calling is Armstrong and passing in I as the parameter here. And then I'll just print I. This is for changing the line \n. And now let's try to compile this code. GCC Armstrong.c, and I'll also use the -lm flag for including the mat.h library. Also, I forgot to tell, this is for using the POW function, power function. You can explicitly run a for loop to multiply that number of times, but I have used power function because it is available in the mat.h library. So I'll try to compile this using this command. Okay, so I forgot to save this. So now I have saved the file. Now again, let's try to compile this. Okay, so I have used a semicolon here by mistake, so this is an error. Let's try to compile this again. Okay, so there is a spelling mistake here too. Now I have saved it again. So now it compiles perfectly. Now let's try to run the a.out file. So it will ask for input. Let's say we give input as 1 and 1000, and I'll get all the Armstrong numbers printed here. So this is the list of all Armstrong numbers between 1 and 1000. You can give whatever input you want. So now let's move on to the next question. So the next question is, we have to find the output of this particular piece of code here. So let's write it down in text editor only. I'll create a new file. I'll copy this code here. Okay. First, let's save this as a .c file. Yeah. And let's also indent this code. Yeah. So let's go through this code and see what the output should be. Also, let's clear the terminal screen. So the compiler will first call upon the main function as I told you. So here we are also discussing upon the scope of a variable. So these variables are declared, as you can see, these variables are declared outside the main function. And leave the main function, these variables are declared outside any function. So since these variables are declared outside any functions, I can use these variables within any of these functions. So these are called global variables. These are global variables because I can use these variables within any of these functions. And then you will see some local variables like this variable. The scope of this variable is within this function block itself. Similarly, these variables are also local variables, and the scope of these variables are within this function block itself. So I'll not be able to use these variables outside this function, the value of these variables. So let's start predicting the output. So I have first declared a local instance of z. Remember, this is different from the global instance z is equal to -3. So this local instance z is equal to 3. Now we'll calculate this expression. So we must have studied the precedence order of the operators. The priority of the unary operators is the most, so this thing gets calculated first. So plus plus z gives us z is equal to 4. Let's also write this down here. Z is equal to 4. Then plus is equal to Both are same, and this operator is right to left associative, so we'll move from right to left. So first we'll do y plus is equal to plus plus z. We have already calculated plus plus z, which is 4. So we'll just have to add y to 4. 4 to y, sorry. Also see that we haven't declared x or y here. So since we haven't declared x and y here, so what we'll use for the values of x and y will be the global values. And since I have used declared z within this main function, so we'll use the local value here. So you will always give priority to the local variable declared within a function. So since z is locally declared here, so we'll use the locally declared value of z while computing all expressions involving z here. And since x and y are not declared here, that is why we are using the global values of x and y. If they would have been declared here somewhere like int x is equal to 2 and y is equal to 3, then I would have used these values only, because always the local variables get priority over the global variables. So now we'll calculate the value of y. We just have to add 4 to y. So y was initially minus 2. So adding 4 gives y is equal to 2. And then I add this thing to x. So y becomes 2 now. I'll have to add y to x. So x was minus 1 initially. We'll add 2 to minus 1. So x becomes 1 now. And we are updating the global values of x and y here and the local value of z here. So what should be printed here? 1, 2, and 4. Now we are passing x and z as parameters into this function f1. So again, here since x and z are the local variables, I'll use the local values of x and z here, and since y is not declared anywhere here, so I'll have to use the global value. But also remember that I have changed the global value of y in the main function here before calling the f1 function. So the value which I'm going to use for y will be this value, because I have updated the global value of y. So let's again start computing the expression. We'll first compute the expression which is within the brackets, since it is given priority first. So first y will become 2 plus 2, that is y will become 4 first. Then again the unary operators will be given priority. So plus plus x will result in x becoming 2, because x was passed. Let's also write the values passed here. X was 1 and z was 4. X will become 2 now, and z will become 3 because we are decrementing z. And finally, we are adding all these values and storing it back to y. So 4 plus 2, 6, 6 plus 3, 9. So what should be printed here? X equals 2, y equals 9, and z equals 3. So I hope this is clear with all of you. Now we are heading into this block. This block, again, we have declared x and y as local variables within this block. So I'll use the local values of x and y for calculating whenever we see x and y within any expressions. So again, plus is equal to and equal to have same precedence. So I'll start from right to left, as these operators are right associative. So first I'll assign z the value of 5 into y. What is 5 into y? 5 into y is 20.0. So since z is of integer type, it will type pass it back to integer. So z will store 20 now. Z will store 20, and I'm adding the value of z to x. X was initially 0, so x will also store 20 here. So again, what I'll get here is x is equal to 20, y is equal to 20.0, and z is equal to 20 again. Sorry, y was 4. So we'll get y is equal to 4.00. Why 0, 0? Because I have used dot 2 here, so this specifies the number of digits after the decimal. So I'll get 2 digits after the decimal. And at the last, this will return the value of x, y, and z. So again, the scope of x and y ends when I end the block. So these values 20 and 4.0, the scope ends here. So now the value of x and y which I am talking here is with respect to the scope of the main function because this block ends. So z was the local variable declared here. And also I hadn't declared z here. So the value of z which I am updating here is that of this variable only because z wasn't declared in the scope of the this block. So also the value which we are using will search hierarchically. So if let's say z was also not present in the main function, then then I would have used the global variable z here and use the value -3 for computing whatever I had to compute. But since z was here, I am using this value. So we'll also serve in a hierarchical fashion and I'll use this value of z which I am using in the main function here. So this is the value which gets updated. So x will now equal 1 only because was the last modified value of x. And here I am not modifying the value of x anywhere. This is the local variable x. And I want to use this value of x here. X will be 1 only. Y will be 9 because x and y here are not present in the main function. So I'm using the global values of x and y only. I had updated the global value of y to 9 here because y wasn't declared in this function. So y will stay 9 and z will be equal to 20 because I had updated the local variable z with respect to main function because z wasn't declared in this block. So z which becomes 20 here. So this is the z which we are referring to. So z is 20 here. So let's see if our predicted output is correct. I'll save this file. I'll try to compile it. Output.c. Okay, so there is again something wrong. Line 6. Okay, so this should have been commented. This also. Let's save this and try to run this again. So it compiled and now let's see the output. So 124 according to what we predicted here. Then 293 according to what we predicted here. Then 24.00 20 this thing. And finally 1920 this thing. So this is what the output is for this piece of code. Let's clear the terminal again. And now let's move on to the third question. So this is the A part. We'll check the output for all of these. So you'll get to know about the return types of the function here. So let's see what is the return type of func here. The return type is void. So you must be expecting a void. Void means null. It is not returning any data type here. So see, in this function also, we are not returning anything. But we are assigning x to the value returned by function here. X is an integer and this function func returns nothing. So what are we assigning x to? It is essentially nothing. So this should give us a syntactical error. So let's see whether this gives an error or not. I'll compile this and see here. We get an error, void value not ignored as it ought to be. So this function returns void here, and we can't assign integer to a void to an integer type. If the function would have returned an integer, let's say int, and I'm returning s here, then this would have worked fine. Okay, so I have not saved it, I think. Okay, so I have to change the function prototype also. So remember these things. I'll compile again, and this time it compiles. So you cannot assign void data type to integer data type. Let's see the next piece. So this time it returns an integer, the difference. This returns the sum. So this should be simple. First, this thing returns the difference of D and C. D is 6, C is 2. So this returns 4. And I'm adding 4 to A. So this should return 24. And then again we are calling difference with parameters B and C. B is 5, C is 2. So this should return 3. 3 comma D. D is 6. So I am now summing 3 and 6. I am passing the returned value by the value returned by diff to sum. So the value returned by diff is 3 here because 5 minus 2 is 3. And I'm passing 3 and D which is 6 to sum. So this will sum 3 and 6 and it will return 9. And then I'm again calling the diff function by passing A and 9. A is 20 here and I'm passing 9. So 20 minus 9 will give me 11. So let's see if the output is again 24 and 11. I'll again compile this and I'll run the a.out file. So the answer is 24 and 11 only. Now the last part of this question. Let's indent this properly. Yeah, so we are defining a function func and we are doing this operation here. So first let's see what happens in the main function. So I would get initialized to 6 and this for loop will run for 2 times because first when I is 6 it will call function func once, then when I becomes 7 it will call func again, and then it becomes 8, so this condition becomes false. So essentially this runs 2 times when I is equal to 6 and I is equal to 7. Now what happens inside this func? Let's see. So initially j is 1. We'll enter into the for loop. We'll print plus plus j. So j gets incremented to 2 and we'll print 2. So j is 2 now. Then we increment this thing j and then we check whether j is less than 3. So after getting incremented, j becomes 3 and this condition becomes false. So we do not enter into the for loop again. So let me clear the control flow of for loop to you once. So what happens is we first check the initialization condition. We first do the initialization. J is equal to 1. Then we check the condition whether j is less than 3. It is indeed less than 3 now. So we'll enter into a for loop. We'll print this. While printing, j gets incremented to 2. After we have entered the for loop for the first time, then we go to the increment condition. Now we'll increment j becomes 3 now. After incrementing, we'll again check if the condition is true. This condition is false now, j is not less than 3. So the loop terminates. So essentially this loop runs only for one time and it will always output 2. So what this should output? 2 times with a tab in between. So let's see the output by compiling. So this is the output 2 with a tab space in between. So now let's move on to the next question. The next question says that we have to write a function in C that takes a number n and computes its square, its cube, and the area of the circle with n as the radius. Okay. So now let's create a new file. Let's save it first. Function.c. Let's start writing the code again. I'll include this time only the stdio.h file. And let's start writing the main function. So what I had to do was write a function that computes square, cube, and the area of the circle. Okay. So let's name this function func, takes as an integer, and the return type will be void because I'll just print inside this function, and this function need not return anything. So let's say I'm taking the value of n as 3. I'm passing this to func here. So first I want to display the radius, sorry, the square. So I'll just multiply in 2 times. Then I want to display the cube. So I'll multiply n 3 times. And then I want to display the area of the circle. So I'll use the format specifier for float this time and print 3.4 multiplied by n square. Area of the circle, it has the radius here. So also let's change the line after each printf statement. And let's also display whatever, not radius, square, cube, and area. Let's try to see whether this compiles or not. gcc function.c. It compiles. Let's run the output file. Yeah. So when n was 3, it gives me the square as 9, the cube as 27, and the area is 28.26. If we change, okay, sorry, so I passed 3 directly here, I'll pass n. And if I change the value of n here, it will accordingly give me the values. I can also take n as input here, declaring and then taking it as input. And now you can pass whatever value you want, let's say 7, then it will give the corresponding values to you. So this question was pretty simple. Let's move on to the next question. So now you have to calculate this series sum. So for this question, I'll use two functions, one for calculating the factorials and one for calculating the sum. So let's start. Let's create a new file. Save it as series.c. Now let's start writing the main function again. So I'll create two functions this time. One for calculating the factorial. So I need a factorial. So first let's start creating the factorial function. This will take as an input n. I'll create a local variable product and I want to return the factorial of the number. So what is factorial? 1 into 2 into all the product of all integers starting from 1 to n. So I'll run a for loop basically starting from I is equal to 1, I is less than equal to n. And I'll multiply all these numbers inside here. So I'll just return the product of all numbers in the factorial function. Now I want to sum this series, so I'll create a sum variable. I'll take n as the input. Initially, sum should be initialized to 0. And then I'll start looping from 1 again. And since each term is factorial of I divided by I, so I'll sum this into the sum variable and simply return sum. So as you can see here, each term in this series is factorial of I divided by I. This term is also factorial where I ranges from 1 to n. So I'm just doing factorial of I divided by I and then ranging the for loop from 1 to n, and this should return the sum. So let's again declare a variable here, take it as input from the user and pass it to sum function and return the sum. Let's save it and now let's compile this series.c. Now let's run the output file. So there seems to be some issue here. Oh, okay. So I have to take an input. So this gives me 34. Let's compile it again and now let's use output as 10. So this gives me this value. So this calculates the series. Moving on to the next question here. This question is for checking whether a given number is prime or not. So let's write the code for this function now. Let's save it as prime.c. Again, let's start coding this up. And I'll create a function check prime, which returns 1. Let's see the conditions. 1 when it is prime, otherwise 0. Okay, so you'll take in n as the input. And when is a number prime? When there are no factors other than 1 and the number itself. So I'll just check for all the numbers between 2 to n and see if there is any number which divides n. If there is any, then I'll just return it is not prime, because if there is any factor between 2 to n, then it is not prime. Otherwise, it is prime. So I'll calculate, store a variable as factors, and I'll loop from I is equal to 2 to I less than n, I plus plus, and I'll check if the remainder upon dividing n by I is 0, then I'll increment factors. And in the last, if I'll check if factors is greater than 0, it means there is some factor between 2 and n. I'll return 0. It is not prime. else return 1, it is prime. Let's check it for some inputs. I'll print the value returned by check prime function and pass n as the input here. Let's try to compile this. GCC prime.c. Now let's output. Let's take it 5 as the input. 5 is a prime, so it returns 1. Again, let's see the output. Let's take 9. 9 is not a prime, so it should return 0. It needs to return 0. So let me also tell you a better way to write this function in a more concise way. Instead of doing this, if, if there is one factor, I don't need to calculate the number of factors here. So if there is one factor, I know that this number is not prime. So I'll return 0 here itself because I know that this number is not a prime. So why to check for further values of I if I know that this I is only the factor of n. So I can return 0 here itself because I know that this I leaves remainder 0 upon division. This n leaves remainder 0 upon division by I. So this means I is a factor of n. So I can return 0 here itself. And if I don't encounter 0, like if condition is never true, that means there is no factor of n here. So this for loop would terminate and the control will reach here and I can return 1 here itself. So let's see if this works also. I'll again compile the code and run it again. Let's check it of 5. 5 is prime. Let's check it for 25. 25 is not prime, 0. Let's check it once again for 7. 7 is prime. Also, you don't need to check for all factors. So you can do one more optimization here. You can check for all numbers till square root of n. If there is no factor till square root of n, then there is no factor further also because you can always partition number into you can write n as square root of n into square root of n. So now there will always be one factor less than square root of n and one factor greater than square root of n. So if there is no factor smaller than square root of n, there is no factor greater than also. So this code should also work. Let's try to compile it. So okay, so I have to include the math.h library here. So now let's try to compile it using the lm minus lim flag for math.h library. This compiles. Let's run the output file. Let's check for 5. 5 is prime. Let's check for 10. 10 is not prime. Let's check it for 47. 47 is prime. So yeah, this works. And I leave the rest of the questions for you to practice. I hope you understood all that I explained today. Thank you for being a part.